It was really exciting. And you know, when you have a revelation, you want to tell someone, right? So I didn't know who to talk to. I wasn't going to talk to the bus driver, you know. And so I ran home when I got out of the bus, and I was waiting for my mom to get back from work. And when my mom came in the door, I'm like, Mom, I figured out something at school today. It's really exciting. And, oh, my mom was so excited because she thought, oh, my God, you finally are doing good at school. Oh, my God. And then I started to tell her about this. And I'm telling my mom, you know, I think you have a dot inside of you that has all the dots and infinite dots inside and all this. And my mom is looking at me with a look of despair. The look of an Italian mother in despair. There's a force in that hasn't been calculated yet. And so she kind of could see it, but she knew it wasn't part of my curriculum at school, and she told me that. And she said, you know, if you answer that in your exam, it's probably not going to go well. And she said, anyway, right now, I just worked 8 hours, and I don't feel infinite. And when she said that, it rang a bell. I mean, she made a point. She made a very important point. I stopped, and I had to think about it. It's like, well, if it's true that infinity is compactified in every point, how is it that we have finite boundaries? How is it that things are not just falling into each other to infinity? And how is it that things exist? How do we define those boundaries? How do we have a finite space in an infinite potential? How can that be together? I didn't know at the time, but actually I was tackling one of the fundamental difficulties in advanced physics. The difficulty of dealing with infinities and singularity, which is really the crux of unification at this time. It took me back. I had to think about that one. I was like, oh, I got to go back to the blackboard. I got to think about this before I talk to anybody else. But eventually, it came to me. And it took a very long time. I was much older by the time I realized. But all the way through my childhood, there was a few things that came through to help me deepen my belief that I had found something very crucial. Was I the first one that came to these conclusions? Have these ideas been around before? Absolutely. Okay? Other people have thought about this. Even our, Big Bang Theory says that everything came out of a point the size of a Planck's distance, which is extremely small, billions of times smaller than an atom. These ideas have been around. Have they been well understood? Maybe not. Certainly, I think some of the masters and some of the advanced beings that have walked the earth may have understood them. In terms of physics, in terms of advanced sciences, it's been thought about, but it hasn't been mapped out. It hasn't been understood in its detail in order to be able to apply it to our current physics and our current math. Why would we want to do that, though? Well, we would want to be able to if we want to be able to understand the fundamental structure of creation, and that fundamental structure implies or involves infinities and finite boundaries all at once, we have to find a way to bring these two together, to understand their interaction, to understand how that works. And if we did that, and if we did so, we would have the key to universal forces. We would have the key of the powers of creation. It would be very powerful. It would be powerful for philosophical reasons, and it would be very powerful for application to advanced science and technology. Now, it took me a while before I realized that there is a direct and intricate link between infinities and finite boundaries, and how to understand them and how to demonstrate it. I found eventually that the key was geometry, the very thing that got me going in the first place in my geometry lesson. And I'm going to demonstrate to you right now, in very simple terms, that you can create infinities in the confine of a finite boundary. That these are not opposite concepts, but they actually are complementary. There is infinities to create finite boundaries, and there's finite boundaries to create infinities. And in order to demonstrate that, I'm going to use a very simple initial graphic. Although this graphic is simple, it is still absolutely accurate to the geometry that we will see throughout the day today. It's not something in left field. It's something that's very important. So here we're going to do this. We're going to generate a finite boundary we're going to call a circle here. And this circle could be a 3D sphere that contains a very specific space. And in that sphere, or in that circle, we're going to put a triangle, an equilateral triangle. Now, the universe is polarized. And the reason why things are polarized is because they spin. Okay, things in the universe are polarized because they spin. Angular momentum creates shafts of rotation that generates polarity. So if you have polarity, then you can accurately have a reverse triangle in that sphere or in that circle. Now, right away, we have one of the most common ancient symbols that we find all around the world. It's called the Star of David, or the Seal of Solomon, or the six-pointed star. We'll talk about this later on in the presentation, but just take notice of it. Now we can continue to add triangles. And now we get smaller stars, baby stars of David. Okay, baby six-pointed stars. We can continue to add other resolution of stars by adding more triangles. Again, smaller stars of David. Every time we create a new resolution, we can define a very specific boundary. This is very important. And here we find a third boundary, so smaller and smaller sphere. we can continue to make smaller and smaller resolution of this geometry. And in fact, if I give this to my computer as a computer code, and I got it to make geometries maybe 5 resolution deep, and then zoom in, and then go 5 resolution deep again, and then zoom in, and then keep doing that, it would continue to do that to infinity. As long as the computer had power and chips would keep working in there, it would continue to make boundaries for thousands of years. However, I would never, ever, ever exceed the first boundary that I've set for myself. Within a finite system, I've demonstrated to you right now that you can create infinite numbers of division, infinite numbers of sets of information. In a boundary is the possibility of infinite division, and thus infinities and finite structures are complementary. Why is this important? Well, if you were taking these principles and applying them to yourself, you could start to visualize, you could start to imagine, you could start to experience that maybe within the confine of the finite structure that you're in is the potential of infinite division, the potential of infinite amount of information. Philosophically, that has a very powerful impact on someone's consciousness. It just happens to be very similar to what many of the masters that have walked the earth have talked about. That within is God, the kingdom of heaven, infinite boundaries, and so on, or infinite potential, and so on. It definitely has an impact on science. Why does it? Well, I'll give you an example. When we discovered biological cells, we had microscopes that were at the maximum of the power of amplification that we could get at the time, and we thought, my God, this stuff is so small, it's got to be the smallest thing that the universe does. And then we discovered an atom. And there's billions of atoms in every cell. That is extremely small. And we thought, oh, that's got to be the smallest thing the universe does. And then we discovered protons and neutrons in the center of the atom. We discovered the nuclei of an atom, and we thought, that is so small. That's got to be the smallest thing the universe does. And then quarks and so on. And what I'm saying here is that every time we find a new boundary, we think, that's it. We found the fundamental structure of creation. The universe goes to that size and then quits. That's it. I'm done. I'm not going smaller. This is way small enough. We did exactly the same thing in the other direction, right? We thought, at first we thought the Earth was the biggest thing, and then we thought the solar system was the biggest thing. Then we found galaxies. Oh my God, that's got to be the biggest thing, right? And then we found superclusters and so on. Now we're at universal size, and we think, okay, that's it. It stops there. Right? Well, what if it doesn't? Now, what does it